Right now, 3 ghost aircraft patrol American skies, carrying technology our enemies can't comprehend. Test pilots who fly them remain silent about what's inside. Defense analysts call it a miracle. The B-21 Raider isn't another bomber. It's America's first 6th-generation aircraft. And what it can do will change everything you understand about modern warfare. So today, we're revealing 5 capabilities that prove why this aircraft terrifies our opponents. At number 5, we have digital engineering revolution. Most defense programs blow past budgets and deadlines. The B-21 Raider didn't. Its success comes from a method called digital engineering. Before any metal was cut, Northrop Grumman built the entire bomber inside computers, every system, component, and wire, creating a full digital replica of the aircraft. This digital twin allowed engineers to test thousands of configurations virtually and fix problems before they became expensive mistakes. Traditional aircraft programs discover flaws only after building prototypes. The B-21 found them in simulation first. By the time construction began, the design was already validated. The approach worked so well, the US Air Force cut about $1 billion from program costs in 2025. Digital engineering also speeds up upgrades. New weapons or electronic warfare systems can be tested virtually before installation, reducing integration timelines from years to months. Early aircraft were built using full production processes, allowing rapid improvements across the fleet and ensuring the B-21 can evolve continuously for decades. At number 4, we have modular open systems architecture. The B-21 Raider uses a modular open systems architecture, allowing upgrades far faster than older stealth aircraft. Instead of years of modifications and testing, new stealth technologies, weapons, or countermeasures can be integrated in months. As threats evolve, the B-21 evolves with them. It's designed not to become obsolete, but to continuously improve. This open architecture also means new capabilities can be added as they emerge. A breakthrough in drone technology can be linked to the bomber. A new electronic warfare system can join the network. Over time, the aircraft becomes more capable rather than less. The design also improves resilience. If one sensor is jammed, others take over. If one communication channel is disrupted, alternatives remain available. In June 2025, the Air Force conducted radar cross-section validation flights, testing the bomber against advanced tracking systems. Observers noted unusual flight patterns consistent with stealth testing, strong signs the aircraft performed exactly as intended. At number 3, we have advanced AI and autonomous capabilities. The B-21 Raider is designed to fly with or without a crew on board. The aircraft can conduct missions autonomously if required. In November 2025, Air Force Global Strike Command made a recommendation that surprised many defense analysts. They proposed that the standard crew for the B-21 should consist of just 1 pilot and 1 weapons systems officer, not 2 pilots like the B-2. 1 pilot. For a bomber expected to fly missions lasting more than 20 hours, that recommendation seems unusual, but it reveals how advanced the B-21's onboard automation truly is. The aircraft includes AI-assisted systems capable of handling navigation, threat avoidance, system monitoring, and parts of tactical decision-making without constant human input. Evidence that this capability was planned from the beginning comes from a heavily redacted Department of Defense Inspector General report from 2015. Among the few unredacted requirements for the long-range strike bomber program was a critical phrase: capable of manned and unmanned operations. This was not speculation. It was a design requirement from day one. The tactical implications are significant. Autonomous systems do not experience fatigue, stress, or decision-making limitations under pressure. AI can process sensor data faster than human crews and react to threats in milliseconds. It can also optimize flight paths in real time as battlefield conditions change. This capability allows the B-21 to perform missions that might otherwise be too dangerous for human crews. Deep penetration strikes into heavily defended territory. Or extremely long intelligence gathering operations where pilot fatigue becomes a serious factor. Autonomous capability does not replace human crews. It expands the range of options available to military commanders. At number 2, we have family of systems and network-centric warfare. This capability may be the feature that truly separates the B-21 from every bomber before it. The aircraft is not simply a platform. It is the central hub of an entire family of systems designed to dominate the battlefield through information superiority. Air Force leaders repeatedly use that phrase when discussing the B-21 family of systems, and it reflects how the bomber was designed to operate. From the beginning, the B-21 was built to function as a node within joint all-domain command and control networks. That means it does far more than deliver weapons. It collects intelligence, shares data, and coordinates with other military assets across air, land, sea, space, and cyber domains. The aircraft's sensor suite integrates radar, infrared, and electronic warfare inputs through multi-sensor fusion, creating a single operational picture that gives the crew exceptional situational awareness. But the real breakthrough is what happens with that information. The B-21 can transmit sensor data to other aircraft, ships, ground forces, and command centers in real time. Imagine a B-21 flying a strike mission deep inside contested airspace. Its sensors detect previously unknown enemy air defense systems. Instead of simply avoiding those threats, the bomber shares their locations with nearby F-35 fighters. Those fighters can then suppress the air defenses, while the B-21 continues toward its objective. At the same time, the bomber's electronic warfare systems may be jamming enemy communications, disrupting coordination, and slowing any response. This is network-centric warfare in action. Every platform on the battlefield becomes more effective because they are sharing information and operating together. The long-range strike family of systems will eventually include unmanned aircraft that fly alongside the B-21, extending its sensor range and adding additional firepower. Advanced communication systems will allow the bomber to remain connected even in heavily contested electromagnetic environments. As General Stephen Davis, commander of Air Force Global Strike Command, explained, the B-21 will carry more sensors and receive more inputs than previous bombers, making it even stronger as a penetrating strike platform. The aircraft itself is only part of the story. Its real power comes from how it connects and coordinates everything around it into a single integrated combat system. And finally, at number 1, we have next-generation stealth technology. The foundation of everything this aircraft can do, stealth. You might think you've heard this before. The B-2 Spirit was stealthy. The F-22 Raptor redefined air dominance with stealth. So what makes the B-21 different? Here's the truth. The B-21 doesn't just use stealth technology. It was built from the ground up around a completely new understanding of how to disappear from enemy sensors. We're talking about 30 years of advancement beyond the B-2. 30 years of new materials, new coatings, new design philosophies, and most importantly, new threats that required completely new solutions. The B-2 was designed to penetrate Soviet air defenses during the Cold War. Incredible achievement for its time. But the B-21? This aircraft was engineered specifically with China in mind. Chinese air defense networks represent the most sophisticated threat environment on Earth. Multiple overlapping radar systems, advanced infrared tracking, network sensors that share data in real time. The B-21 was designed to fly through all of it undetected. Look at the physical design. That smooth, continuous flying wing shape isn't just for show. Every curve, every angle, every surface has been optimized to scatter radar waves away from their source. But it goes deeper than shape. The B-21 uses advanced radar-absorbent materials that are lighter and more durable than anything on the B-2. Here's something the Air Force rarely discusses. Stealth isn't just about avoiding radar. Modern air defense systems use infrared sensors to track the heat signatures of aircraft. The B-21 addresses this with some of the most sophisticated thermal management systems ever installed on a bomber. The engine inlets are deeply recessed, hiding the hot turbine faces from infrared sensors. The exhaust system routes hot gases in ways that minimize the thermal signature. The B-21 represents 30 years of silence, secrecy, and groundbreaking innovation. While the world watched other programs fail and burn through billions, this bomber stayed hidden, stayed on budget, and delivered exactly what it promised. The bomber's name honors the Doolittle Raiders, those brave men who launched an impossible mission in 1942 that changed the course of World War II. That same spirit of innovation, courage, and determination lives on in every mission the B-21 will fly.